The only downside to setting up your own SSID without encryption is, well, anybody can intercept it. The nice thing about a wired network is that the only way people are going to intercept what you're talking about is if they can plug into your switch or something like that. But a wireless network, it's radio waves, folks. It's up in the air. And anybody with a radio receiver can intercept everything you're saying. So it's very important to us that we encrypt the connection that goes between our wireless clients and our wireless access points. So people have known this from day one. The original 802.11 standard had these pretty terrible encryptions built into it. One of them was called WEP. Interestingly enough, this pretty advanced 802.11 AC router still has WEP settings in it. Let me at least show you real quick. So right now I have no security. Notice I'm in the 2.4 gigahertz band because this is how old this is. So we can go into WEP. WEP was this awful thing. We'd have to type in some hexadecimal value. How's your hex going these days? Well, and I have to make, on this, it has to be 10 characters. If I don't make it 10, watch, it complains. Whoops, let's put it on hex. Should be 10 hexadecimal characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it buys it. Fantastic. The original WEP used these keys that everybody had to know. So whatever gobbledygook I typed into my wireless access point, you had to know those on the client. So it had to be told by word of mouth, which is okay. The problem is that WEP used an ancient form of encryption known as RC4. And for stirring up stuff, unfortunately, it was predictable and people were able to hack it mechanically. They were able to just instantly crack it. Think of this encryption as using a key that was like a secret decoder ring, but the secret decoder ring just clicked one time every time in a predictable fashion, and WEP was a disaster, and it's not a good thing. Take my Network Plus course. I'll show you how to crack WEP in about 30 seconds. So everybody started to panic, and the Wi-Fi Alliance got together and they were working with the IEEE. They're going to come out with a new standard called 802.11i. And 802.11i, first of all, was going to have authentication, where you had to type in like a username and password or shove in a smart card or something just to get onto the wireless network. So that was good. And then it was going to have really robust encryption. And they were going to do, for example, they took the original RC4 and they improved on it using something called TKIP. And TKIP basically spun the secret decoder ring in a less than predictable way, which helped quite a bit. And then they were going to get rid of that altogether and come up with a much more robust form of encryption known as AES, which is still used to this day as the primary encryption for everything from secure web pages to voice over IP calls to you name it. AES is tough stuff. And everybody's like, yay, thank you, IEEE. When is this going to happen? Keep in mind, I'm talking 2002 here, folks, 2003. And the IEEE is like, well, it'll take us 3 or 4 years. And suddenly Cisco and Linksys and all these people making wireless access points are like, oh, no, 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 no. So they got together and they said, okay, what parts of 802.11i can we do in-house even though the standard isn't out yet? And one of the things is that they could take the RC4 and add this TKIP thing, which would make it much harder to crack. And the other thing is they added a new way to authenticate. So you had 2 choices. You could do the pre-shared key, which was kind of like WEP. There's nothing wrong with pre-shared key. They also call it personal. What we do is we type in a code in here, and then when anybody needs to get on our wireless network, we have to tell them. And anybody who's ever walked into a coffee shop has had the, hey, what's the code to get into the wireless network? It's because you're using a pre-shared key. But there's another way to do it, which uses a special box called a radius server. A radius server is something where you actually have to log into with a username and password, and it's a separate box that'll be on your network. And I'm pretty good at configuring just about anything, and I got to tell you, I tried to configure the built-in Microsoft's radius server, and it's hard. So most people, when they're setting up their networks, they use this TKIP, and then they go ahead and they use personal shared key. These 2 things are a great improvement on WEP, but they're not 802.11i. They're simply called WPA. So WPA is, when this was first coming out, was as close as the industry could get to the 802.11i standards. To get a wireless network card to decrypt AES was a bit of a pain. So a few years later, after the hardware caught up, they were able to come up with basically 802.11i. It had all the same features, but the standard still wasn't out, so they called it WPA2. And WPA2 has been out for a good while now, and pretty much all of our wireless access points, all of our wireless network cards can easily handle WPA2. When we're setting stuff up, you will use WPA2. So WPA and WPA2 pretty much set up the same. Let's take a quick look. So here's WPA/WPA2 personal. And here's where we have to type in some kind of password, and this is what we'll share with everybody else. However, you can also do WPA2 enterprise. Now when you do this, you are bringing in another box, and it's going to have an IP address, and you're going to have to know what its IP address is and type that in. It uses port 1812. It's going to have a password just to get into the Radius server for configuration. This isn't for the individual accounts that are being placed in there. Now, what's interesting is people start to mix this stuff up. So what I want to do is I want to go back to WPA2 personal. Now, if you take a look here, I can choose auto, which is probably almost guaranteed to put me to WPA2 personal shared key. That's what that stands for. I'm just going to leave it as there. Now here's the interesting part. You see encryption? It says either auto or TKIP or AES. If you click that, you are fixing yourself at WPA. If you click that, you are fixing yourself at WPA2. The chances are, as we are now in the third decade of the 21st century, that you're going to run into somebody who actually has a WPA wireless NIC is so small that I would just set everything to WPA2 and AES, and it's going to get there. Different wireless access points change this setup a lot. Just make sure you know that TKIP is WPA and AES is WPA2, and you're going to be in great shape. So, setting up security for our individual SSIDs is simply a matter of going into the wireless access point, choosing WPA2 personal shared key 95% of the time these days, and making sure that you have a good, robust password. And that's just about it. Remember, you need to do this for every SSID you've configured. On this particular system, I've got 2 separate SSIDs, and I'm going to need to set this up for both of those. Okay. Now I'm going to show you a much easier way to set up WPA2 personal shared key just by pressing a button. This is called WPS. WPS was designed because people were having trouble setting up WPA2 personal shared key. So we began to see routers and devices that were WPS capable. In fact, I've got a couple right here. So what I want you to do is take a look at the back of this Soho router, and you see that blue button? It says WPS. If you press that button and then press a button on any WPS capable device within earshot of this, they will automatically configure themselves. There's nothing else to do. Take a look down here one more time. See this printer? If I want this printer to wirelessly connect to this guy, I press the blue button here, I count to about 10, then I press this WPS button, and in less than about 15 seconds, they automatically configure themselves. They set up their own personal shared key. I don't have to do nothing. Now, so that sounds good, right? Well, there's some problems with it. Let me show you one problem with WPS right here. So this router has WPS capabilities, and you'll see it's turned on. So if you take a look, I have a little 8-digit code here. The problem is this 8-digit code is transferred in 2 pieces. So you've got less than 10,000 chance to be able to guess what these 2 pieces are. From a computer standpoint, this is trivial. The bottom line is WPS is incredibly easily hacked. And most devices today, they say simply don't use it. So you notice I've got an option here where I can turn that off, and I'm going to go ahead and turn that off. If you have to use WPS, like some people just, the convenience is so overwhelming. If you have to use it, keep in mind that a lot of these home routers today, what they'll do is if you try to guess their code, it'll go wrong, and then it starts to make you wait like 5 seconds. And then you guess it wrong again, then it makes you wait 10 seconds. You guess it wrong again, you get the idea? So it's designed to help protect people from evil hackers like me who try to guess the password 7,000 times in 1 minute, but it's still pretty weak. So the bottom line in life today is, in a small office or home office environment, you will set encryption, and that encryption will be WPA2, and it's going to be personal shared key. Setting up a wireless network in an enterprise environment is very different, but also very much the same as it would be within a small office or a home office. You still have SSIDs, you still have encryption, WPA, WPA2. None of that stuff changes. The bands are there, the versions of 802.11 are there, but it gets a little bit bigger. One of the big differences we have in an enterprise environment versus a small office, home office, is we tend to use dedicated wireless access points. These are real WAPs. These are not routers, they're not switches. All they are wireless access points. And we tend to have lots and lots of these wireless access points laying around. Now, if you've ever looked at the walls, and if you're a nerd, you're going to start looking at walls a lot, one of the things you go, hey, I see these wireless access points laying around, but they don't have any AC adapters. Well, there's a very good reason for that. And that's because the vast majority of these types of devices are what we call power over Ethernet, in that these devices actually get their electricity from the Ethernet cable that they connect to. In order to take advantage of power over Ethernet, number one, you have to have devices that are PoE capable, and you got to be careful here. There's two versions of PoE. There's first generation PoE and PoE Plus. PoE Plus provides a lot more electricity for individual devices. And so you have to have either PoE or PoE Plus wireless access points. You need a good chunk of cable, and here's the big one. You have to have a PoE switch. So this switch has to be designed to actually send out not only all the communication, but also the electricity. So you'll see these switches that are PoE or PoE Plus. PoE Plus is very dominant these days, and if you run into PoE, it's a rare thing. The nice part about PoE is that you don't have to plug any of your access points into a wall. Now, if you don't have a PoE switch, you can use something like this. This is a PoE injector. I can plug an AC adapter into this, I can plug this into my switch, and then plug the other end into a PoE wireless access point, and I get the same benefit of having an actual PoE switch itself. Okay. Now, once you've got this configured, and whether you're using PoE or not, in an enterprise environment, a few things change. The first thing that you really start needing to talk about is where are my wireless access points and their antennas going to go. So let's draw up a little diagram using, this is more of a heavy-duty enterprise tool that's going to be helping me figure out where to put my WAPs. So here's a typical office environment. I've got a really big office on one side, I got this long hallway, and then I have some small offices on the other side. Where we place WAPs can really be important. So like, for example, do I want to provide coverage in the hallway? If that's the case, I'm probably going to put very directional antennas on one or both ends of this to provide coverage. Remember, they provide a big, long, narrow football shape. If I want to do individual offices, I could put a dipole right in the middle, but another alternative is just to put patches on one side. And that way with patches, it's putting out information out into the room, but it's not sending stuff outside where other people can get a hold of it. In larger areas, I might want to just consider using dipoles or omnis. Depending on the actual coverage of the space, that will give me some idea of how much coverage I actually need. Now, one of the things you can do, and again, this is with more enterprise type wireless analysis tools, is you can actually start placing wireless access points, and they'll do what's called a heat map. So let's put some heat on this. So you can see where the red is, that's where the highest coverage is, and then it dissipates out in a rainbow, giving you a good idea of where you might have dead spots or spots that are actually shooting out outside of what you're interested in providing wireless coverage to. Now I need to warn you, the type of wireless analysis tools that do stuff like this are not free. You're going to be spending a couple of grand on something like that, or actually more often than not, you're going to be hiring wireless professionals to come in, and they're going to go ahead and do a really aggressive site survey with heat maps and all this stuff to help you get not only your wireless access points, but the types of antennas placed in the right spot for your environment. The other big change that takes place when you go from SOHO wireless to enterprise wireless is AAA. AAA stands for authorization, authentication, and accounting. What we're talking about here is basically you're going to be using WPA2, but you're not going to be using personal shared key. What you're going to be using are either Radius or Takakis Plus boxes that will actually provide the authentication you need. So when someone logs into a network, they're not just going to suddenly know the private shared key. Their client is going to make them sign in with a username and a password, and assuming they get that, then they're assigned their WPA2 information and they're in good shape, and then they actually connect. So when you're talking about AAA, you're talking about very, very aggressive authentication and authorization to make sure we don't want just anybody jumping on this. And you can add things like smart cards and all kinds of extra stuff, but in general, it's usually just a username and a password. Now, if you're going to go through all this, you still have to go through the process of configuring your wireless access points. So what I've got right here is I've got 2 wireless access points, and I went ahead and figured out what their IP addresses are. Most of the time when you get enterprise level WAPs like these, they're going to come with disks, and you basically plug any computer into this switch and it will go out and query them as a group. In this case, we're going to do them individually. All right, so here I am in one of these 2 wireless access points. First of all, the big thing you're going to notice, there's nothing in here but wireless. There's not going to be any firewall settings or DHCP servers. That's not what these are for. It's just a WAP. So I've got a quick summary here, and I can check my LAN status, for example. I can see what my IP address is, my default gateway, all that type of stuff. My wireless status right now, I don't have anything turned on. It's all turned off for the moment. And obviously I won't have any wireless clients. So I could do a quick start, but what fun is that? Let's go to configuration. Now the first thing is I'm going to have user accounts. These are accounts that can actually log in and do stuff to these wireless access points. So for now I'm just going to keep the default, which is admin, admin, but you would normally change this. So the next thing I'd be doing on the LAN side is I'd probably want to give it some kind of descriptive name, because if I have 500 of these, I'm going to want some kind of name that helps me remember all of them. Now the other thing we're going to do is probably set static IP addresses. I'm going to leave it as DHCP for right now, but if these were my wireless access points, I would start, for example, 10.11.12.10, .11.12.13. I would have a bunch of these all preset on static IP addresses, because I don't want this address to change at any time. Now on the wireless side, a lot of this stuff should look pretty familiar. Let's go ahead and set up a basic SSID. So I've got a radio 1, and it says N only, G only, B, G, and N. So we know, just because we know our different 802.11 extensions, that this is a 2.4 gigahertz radio. So what I'm getting ready to do is set up SSIDs for each one of these individual devices. But that rarely happens in an enterprise environment. In an enterprise environment, what we're setting up is called an ESSID. An ESSID is a single SSID name, whatever you want to call it. We call it Mike 24, Mike 50, but it's the same SSID on all of the different WAPs. If you set up the same SSID on a bunch of different WAPs, and if all these WAPs plug into the basic same local area network, you will create an ESSID and magic things happen. For example, by setting this up, I could be closer to this WAP and I'll be connected there on my Google or whatever, but as I walk across campus or whatever it might be and get closer to this one, it will automatically hand off. I don't have to do anything. There is nothing to configure. It just works. And I'll just pick up from this guy right here. It's as though I never disconnected from anything. There is actually a millisecond handover, but it's really, really quick. So the secret to an ESSID is make the same SSID on all the different devices and make sure they're all a member of the same LAN. Got the idea? Okay, so, because we're going to do this the hard way first, then I'm going to show you an easier way. So I'm going to enable this one, and because I know this is the 2.4, I'm going to call it mic 24, and I'm going to broadcast it. Now here's another setting I want you to be aware of. This is called isolation. In a wireless isolation, what's taking place, normally with a wireless network, if you've got your network discovery turned on and stuff, you can share folders and files and do anything you want. It works great. However, if you do isolation, what's going to take place is that the only computer on the network your wireless clients can talk to is the actual wireless access point. They won't even be able to share folders or files. They wouldn't be able to ping each other. So it's a really powerful way if you want like a coffee shop where you want people to be able to get on the internet, but you don't want them passing folders and files. So isolation is very convenient. And we can set this up to be on a particular VLAN. I'm going to leave it at the default from here. You can even set the maximum number of clients. So I'm going to go ahead and save this. Now I'm going to go over to radio 2, and you'll see it says AC only, so I instantly know that this is my 5 gigahertz radio. I'll enable that. Call this one mic 50. Turn on the broadcast. Leave isolation alone as it is for right now, and hit save. So while I'm in here, I can even set up security. So for example, by default it goes to WPA2 personal with AES. I've got a pre-shared key set up. Let's check the other radio. And that's mic 5.0. So one more thing back here. Notice how many different SSIDs you can make. This can be really convenient. Like this could be the office and this could be guest, for example. So in the office one, I could keep isolation turned off, whereas in the guest one, I would turn isolation on, that type of thing. So I can really have some powerful tools. Anyway, the next one I want to talk about is rogue AP detection. One of the most frustrating aspects to a wireless network is if somebody walks up and fires up their own access point. It happens all the time. What we can do is we can set this up. All of these access points have a MAC address, and they'll all know each other's MAC address. That way, if any other device tries to act as a WAP and it's not on the list of known MAC addresses, they'll simply block it. They won't use it. It'll be ignored. And in fact, on more advanced systems, we can do things like set up jammer systems and bring in guys in helicopters. Okay, maybe I'm kidding about the last part, but rogue APs are a real problem. So we're always looking about ways to get out of trouble with those. One of the most important things we can do is if you know what you're passing out. For example, I've got a DHCP server somewhere. It might be passing out 10.11.12s. And suddenly one day I fire up my network and I'm on the wireless network, but suddenly I'm getting 44.66.8. Hey, wait a minute, that's not an APIPA, but that's not my proper network ID. This is why I yell at people all the time. Know your network ID for the networks you dwell upon, and that way when weird stuff happens, you're ready for it. So rogue access points, a big problem. But there's more, let's check it out. So one other option you'll see a lot of times is what we call a rate limit. I can actually throttle the speed that that particular SSID might be doing either upstream or downstream. So that can be pretty handy. Okay, well, we've got one set up, but now if we want an ESSID, we've got to do this all over again. Every single wireless access point on my ESSID needs to be configured. I'm going to have to go back into each one of the radios and set that mic 24 and the mic 50. I've got to set a bunch of these up in order to have an ESSID. Well, all right, well, I'm made of tougher stuff. I can do this. But there's one more thing I want to show you, and that's what we call a captive portal. Everybody's seen a captive portal. A captive portal is one of those things where you click on it and all of a sudden it makes you log in or type in your room number or something like that. So, for example, on this I can actually customize a page. We can get a little peek what it looks like, where I can make them type in a username and password. This is not a Radius or a Takakis username and password. This is something where we create our own users for our own ESSID. We're already starting to run into a problem here. I'm setting up all of these individual WAPs, And if I start putting users on them, they better be identical. Same name, same password. What we do instead is we start running into special wireless LAN switches. A wireless LAN switch is a switch. It's got PoE in it. But what we do is instead of configuring a whole bunch of wireless access points, we go into the switch and we set up one ESSID, which is then propagated out to all of the different wireless access points. Or if we want to set up a captive portal, we set up one captive portal and all the usernames are propagated out to all the different wireless access points. And that's where the real big difference comes into play. The individual cost of a wireless access point these days is sub $100 for a pretty good one, a couple of hundred for a very good one. But where they get you is with these specialty switches that, well, they're switches, but they're switches that are designed to work with wireless access points. They're expensive and they're powerful, and the only place you're going to be seeing those is in an enterprise wireless network. I'm old. In fact, I'm so old that I remember using the internet heavily long before there was anything called the World Wide Web or web pages or anything like that. I know it's hard to imagine that without opening up a browser you could do anything on the internet, but you could, my friends, and I'm going to show you a couple of those things right now. I want to talk about one of the earliest application protocols ever used on the internet. It's called Telnet. Now, it uses port 23. And to understand Telnet, you have to understand how the internet was back in the old days before we had things like Windows and pretty Mac OSs and stuff like that. What you had is you had operating systems, but all you had was a command line. So what Telnet did is it allowed me to sit at my computer in my house but access another computer. But if I was standing in front of that computer, all I'd be seeing is a command line, right? So Telnet simply did that. It was a remote command line tool, and by the way, it still works beautifully today. It's a very, very powerful tool, and it allows me just to get to a command line on some other operating system. Got the idea? Great. Now, in order to access a Telnet server, I have to have a Telnet client. In order to access a web server, you have to have a web browser, right? Well, you'll also have to have a Telnet client, and the Telnet client that's probably the most common and popular is something called PuTTY. In fact, PuTTY has been around for a long time, but it's been constantly updated. It works incredibly well. And if you don't know what PuTTY is, I really don't even consider you kind of a networking person. It's that common of a tool, and it's in every text toolbox. Now what's cool is that PuTTY is a client for a lot more than just Telnet. In fact, we're going to see a big brother of Telnet called SSH in just a moment. But first, let's use PuTTY to access Telnet. So what I've got here is I've got PuTTY up and running on my computer, and we're about to access a Telnet server that's far away. But I've also got my command line locally open just because I want to run netstat so we can actually see the connection. You ready? Let's do some telnetting. This is PuTTY over here, and this is the main screen. You'll notice I'm set to Telnet, which is port 23. And all I have to do is type in a fully qualified domain name, or I could type in an IP address for a Telnet server. So this is the actual name of my Telnet server. So I'm going to hit open. Now, I'm going to run netstat really quick. Do you see right there? That is the connection that's being made. So my computer is sending out on port 23, and it's going to this computer right here. Okay, so Telnet needs a password to get in. So I'm going to type in a username, which is going to be Mike M, and the password is total. And there's a nice little header. And now I'm actually in the command line, which in this particular case happens to be a Linux box, so I better type Linux commands. Or you could be like the guy who set up this Telnet server and has left absolutely nothing in there for me to look at because he's giving me good security. Telnet is fantastic, and it is a great way to access all kinds of stuff. Here I'm just accessing another computer, but you'll see Telnet being a way to connect to a lot of routers and switches and things like that. But Telnet has one huge problem. It is completely unencrypted. Anybody who's between me and my Telnet server can intercept and read the data, including that username and password that I typed in. That's all in the clear, and anybody can intercept it and then potentially use it against me. So it's really important for us to be able to get to other people's command lines. However, I don't want the data between the client and the server to be in the clear. So we're going to stir it up. We're going to mix it up. We're going to encrypt that data, and we're going to do that using Telnet's big brother, SSH. SSH also just gets you to a command line. However, it'll be point-to-point encrypted, as we say, and we don't have to do anything. It just automatically encrypts. It's a wonderful, wonderful thing. So let's go ahead and do this all over again, except this time we're going to use SSH. By the way, SSH uses port 22. So here we are back to PuTTY again, and I've got my command prompt open here. I'm going to click on SSH in this case. Notice it moves over to port 22. So now I'm going to type in the fully qualified domain name of my SSH server. And yes, this computer, which is a Telnet server, is also an SSH server. A computer can be more than one kind of server at once. Now, one of the things that's going to happen with SSH is that it's going to send me a key so we can encrypt stuff. So it pops up and says, do you want to store this key? And we hit yes, otherwise we're not going to be able to work. So I'm going to run netstat -n again. And if you look down here on the bottom, you can see my SSH connection is now connected. So I need to log in, and ta-da, and I guess this one's going to be just as empty as the other. It is. But you've now made a good SSH connection. So keep in mind, the only times you're going to be running Telnet or SSH is because you need to connect to something's command line remotely. So you'll see it in some situations. For example, a lot of routers will allow you to run Telnet or SSH, and a lot of different boxes, more than anything else, will often have Telnet or SSH connections. Now, what's interesting is once you get to those command lines, you better know how to run the command line, whether it's Linux or Mac or Windows or whatever it might be, but at least we can get you there. The last thing I want you to remember about these types of connections is that Telnet is completely unencrypted. So I might use Telnet to connect to a router that's sitting right next to me, but if I need to go to the internet to make any of these types of connections, you will only use SSH. Now, connecting to a command line interface is cool, but if you really want to be great, why don't we connect to a remote desktop? Let's face it, today's operating systems are often using graphical user interfaces, and if I want to connect to another system, it's often more interesting to me to be able to actually connect to a desktop on another system. So there's a lot more to this than simply connecting to a command line interface. We have to emulate mouse controls, we have to deal with graphic resolutions differences, so there's a few ways to do this. Now, in the Windows world, we use what's called Remote Desktop Protocol. RDP runs on port 3389, and it's pretty much unique to Windows. So what I'm going to do is, I've got two computers up on the screen right now. I've got one of them I'm going to set up to allow people to use RDP, and then we'll go connect to it with the other one. So I've got a Windows 7 and a Windows 10 system. RDP's been around for a while, and it works fine with just about every version of Windows. So first of all, here I am in my system properties, and I've got two choices here. One says allow remote assistance, and the other one is remote desktop. The differences between these two is subtle but important. With remote assistance, if somebody connects into my computer, it's as though we've got two mice and two keyboards. I can see everything they're doing. They can see everything I'm doing. With remote desktop, what we're doing in that case is we're simply making a connection to another computer. Once you're connected, nobody else can connect to it. Now, these are actually very convenient. For example, if I got a bunch of Windows Server systems sitting in a rack far away, RDP is the way we go to configure those servers. Nobody wants to walk all the way to the server room. So let's go ahead and connect to this system using RDP. I'm going to allow remote connections and just hit OK. Now I need to know my IP address or computer name, so I'm just going to run command, type ipconfig. So now, coming over to this other system, I'm just going to type in remote. So there's remote desktop connection right there. And I just need to type in the name of the computer I want to connect to. It's already there because I tested this before we tried it. And I'm going to hit connect. It cannot confirm that this is exactly the machine I want to connect to. I'm just going to say go for it. It's on my LAN. I trust the system. So right now, someone else is connected. So if I go ahead and hit yes, it's going to disconnect that other person. And you'll see it's giving me a warning. So the one on the right goes blank. I know it looks like a login screen, but it's blank. And now I'm actually connected to this other computer. You can't see what I'm doing on here because I'm logged in as a different user. However, I could do whatever I want to do here, and I am actually connected to that other system. Well, it's kind of boring. You can't really see anything. So what I'm going to do is go over to the C drive, and I'm going to create a folder. I was here. So I've got that folder made, and what I'm going to do now is I'm just going to log out. I'm just going to close this, which will log me off of that other system. Now I can come over here, and there he was. I was here. Absolute proof that remote desktop protocol worked exactly as we wanted it to. So RDP is great, but it's really more of a Windows thing than anything else. If you want to start using other types of remote desktops, getting to Linux boxes, getting to Mac systems, we use a different protocol called VNC. It's probably the most popular third-party protocol out there. In fact, VNC is built into pretty much all Linux and Mac machines. However, it's not built into Windows. So in order to take advantage of this, I had to get a program that runs on top of the VNC protocol called TightVNC, which is completely free, and I've got it installed on here. So let's fire up TightVNC and let's go see some other computers that are out there. All right, so I've installed TightVNC on here. Now, TightVNC is both a server and a client. So when you install TightVNC, you get all this server stuff, but I just want to run the viewer, which allows me to connect to people who are sharing their stuff. So we're going to connect in here, and all you have to do is type in the IP address or the fully qualified domain name. So I'm going to hit connect. Now VNC has a password built into it, which I've got ready to go. And hey, check this out. Look, man, I'm on Ubuntu Linux. How cool is that? So what I want to do now, that's so much fun. Let's do it again. Because TightVNC is built into all Macs, it's a great tool for connecting to Macs. But you can see that I'm running a Mac connection and a Linux connection at the exact same time. The only protocol you need to memorize for the exam is that RDP uses port 3389. I want you to remember that when it comes to remote desktops, Windows is fine with RDP, but VNC works on every single operating system out there, even Windows to Windows. If I'm making connections, I'm probably going to be going with a VNC protocol if I'm going to operating systems other than Windows. Ah, the World Wide Web. I can't tell you how many times I've gone up to a user system who says the internet's down and it's just because their web browser's messed up. And I tell them, oh, the internet's working just fine. In fact, your connection to the internet is working just fine. You're just having a problem with a web browser. The World Wide Web has certainly become the predominant way that most of us look at the internet. Now, the World Wide Web is always going to manifest as some kind of web browser. And these names have become famous with names like Chrome and Firefox and Edge and Safari. These web clients are on every operating system, and most operating systems have multiple choices when it comes to these types of tools. Now, the protocol that's running underneath it is either going to be HTTP, which runs on port 80, or HTTP Secure, HTTPS, which runs on port 443. So if you're going to be making connections, you're going to have outbound on port 80 if it's insecure, or if it's secure, you're going to be going outbound on port 443. And when I say insecure, traditional HTTP is wide open, it's in the clear, anybody can intercept it and read anything that you're doing. So first, let's start with going a little bit old school, and we're going to connect to an insecure website. So I've got my Chrome web browser up here, and if you look very carefully, you'll see it says HTTPS, and there's a little lock, which telling me this is a secure web connection. So what I want to do is connect to an unsecure web connection. So first of all, this machine itself is actually running a web server. So I could type http://127.0.0.1, which is my loopback, which means connect to myself, and all of a sudden I get this pop up. So I'm actually running a web server on this computer. So if we type netstat -n, you're going to see, now I need you to look really carefully here. There's two connections. One connection is my computer connecting to the server. Do you see that? And this connection here is the server connecting to my computer. Let's go ahead and do one more insecure connection, and I'm going to type in something called neverssl.com. This website is actually intentionally left insecure. Now you'll see what happens here. First of all, the browser says, this is not secure. I can click on information here, and it's telling me that I'm running HTTP, so it's pretty clear. Now I'm going to run netstat again, and now this time you'll see I've got two different 80 connections. This is my connection that I had to myself, but here's this other connection. Do you see this? This right here is my connection to neverssl.com. HTTP with port 80 might be fine for configuring a router that you're directly connected to or something like that, but it is something we never do when you're on the real internet. What we do is we do everything with HTTPS running port 443. The trick to understanding HTTPS is that it encrypts everything. And if you were watching my episode talking about Telnet and SSH, when we made that SSH connection, the first thing the server did was hand me down a key. Now that key will encrypt everything. That's fine when I'm running SSH, because I know that SSH server, I set it up myself, or at least my buddy Bob did or whatever, and I trust them. The problem is when you're on the web, you're going to a lot of anonymous web pages. And when you go to www.stuffiwanttobutidon'ttrustthiswebsite.com, and it passes you down a key, you want somebody else to sign off on that key and say, yes, this key is a good, safe key. And there are companies with names like VeriSign and Komodo and Thwate, and all they do is sign off on keys, creating what we call a certificate. So certificates are the keys that allow us to encrypt a connection that are signed by a third party saying they are good. Now, certificates have tons of information in them. They're going to have a key, they're going to have a date they were issued, they're going to have a serial number from the authorizing body, they're going to have the name of the exact website that they're going to be connecting to. There's lots of information in there. And if any of these things go wrong, you've got a problem. And as a user, you need to be able to recognize these problems and make a decision about what you want to do. Now, you got to be careful here, because the methodology by which we encrypt HTTPS is known as either Secure Sockets Layer or Transport Layer Security. It's called SSL or TLS. So a lot of times when we're talking about security on web pages, we'll use the term SSL. So I know it sounds like SSH, doesn't it? Two totally different animals, okay? So be comfortable with that. So what we're going to do is let's take a look at some bad certificates. Luckily, we've got a really convenient website that gives examples of these so we can look at them and know what we want to do. So we're going to go to a website called badssl.com. This is a wonderful place. And if you're an instructor, you need to check this out because it gives great examples of all kinds of bad certificates. One of the most problem child we have is an expired certificate. Now, how this is going to pop up depends on the web browser. In this particular one, I'm using Chrome, and this is how it's going to show up. Now, whenever you get some type of problem like this, the browser is going to show you, probably in red or something, that there's a problem. But then what it's going to do is it's going to give you some kind of information that says what's wrong with this certificate. In this case, the date is invalid, which probably means it's expired. Expired certificates happen. People forget to renew their certificates, and even some of the most important websites on earth have been known from time to let a certificate expire. It happens. So when you see an expired certificate, you've got to make a call right now. Are you going to stop and go, as they say, back to safety? Or you're like, wait a minute. I know these guys. Maybe it's an in-house web page or something like that. Let's just go ahead and do it. So all of these browsers will give you some way to ignore the certificate problem and then go in. So on this one, it's under Advanced, and there we see an option that says Proceed, and it's unsafe. And ta-da, we're in. So that's one example. Let's take a look at a little bit scarier example. So I'm going to come back to bad SSL, and another one that really makes me nervous is a revoked certificate. Once again, every web browser, now they're all different, this is how Chrome does it, but they're always going to give you some kind of information to let you know what's going on. A revoked certificate is a bad thing. This basically means that either somebody has been caught doing something naughty, or they refuse to pay for a certificate and it's been literally yanked from them by the issuing body. If I see something like that, I am definitely not going to proceed any further. Thank you, elders of the internet, for creating certificate hierarchies that allow us to be able to know what's safe and not safe. Let me show you another one that's not nearly as scary though. This time we're going to click on a self-signed certificate. All right, a self-signed certificate is going to give you some kind of information. In this case it says authority invalid. Let's say we've got a little in-house web page, okay? And we have a certificate on there because we want to keep it encrypted, but the only people who are connecting to this are employees or people in a particular department. So we don't want to spend the money to have a full-blown certificate. In this particular case, I'm going to be looking at who I'm connecting to, and if it's my, local website.totalsem.com, then I'm just going to go ahead and go through, and I'll accept that because I know that it's my in-house. Cool, and I'm on a self-signed website. The most important takeaway from all this is that certificates are often taken away for some reason or another. Every web browser out there is going to pop up some kind of warning, but it's really up to you to read it, understand the situation, and make your own call as to whether you proceed or run away. Okay folks, it's your buddy, the great Mike Strami here yet again to talk about troubleshooting issues. Now I'm going to do it a little bit differently this time because we've already covered so much troubleshooting in networking that all I want to do is wrap it up with a couple of little Zen concepts that I want to make sure you understand. Look, the A+ is going to be filled, and I mean filled, with big, long, hairy-looking networking questions that are really pretty simple as long as you stick to a couple of basic rules. Number one, understand how networks work. And number two, go with a couple of rules that always work for me. Number one, don't let the physical get you down. If you think there's a problem with your physical network, always check that first. Check your link lights, take a look at the lower right-hand corner on a Windows system or upper right-hand corner on a Linux or a Mac system and verify that you have actual connectivity before you start blaming anything else. Now, once that's out of the way, there's some other things we can do. Number one, ye shall know your network. In particular, it's absolutely imperative that you know your network ID, that you know what your router is, and that you know what your DNS server is. It's so easy to do. Just run ipconfig. In fact, let's run it with the /all. When you run this, you automatically get all the information you want. Here's your IPv6 address, here's your IPv4 address, here's your default gateway, both in IPv6 and IPv4. If you have a DHCP server, it's going to tell you where that is right here. If you've got a DNS server, and you do, it will show you right here. You should know this. You should know this before there's a problem. I don't care if you're at home or at your office or in a big, huge enterprise. If you're in charge of IT, you make sure you just know these things and you document it. Take little pieces of paper and draw circles with network IDs in them and stuff so that when trouble comes along, you'll know what to do with it. The other tool you need to know is that you need to know your internet connectivity. So most of us have some router someplace, but in a lot of situations, we may have 2 or 3 internal routers before we get out to the actual internet itself. And anytime someone says the internet's down, it would be nice to be able to check to see if you can get a connection. And that's where a very powerful program called traceroute comes into play. The power of traceroute is you run it when everything's good, so you know what it's supposed to look like, and then if something's bad, you can deal with it. Let's run traceroute. So it's spelled traceroute like this in Windows, but it's traceroute spelled all the way out on Mac and Linux machines. So what we're going to do is we just want to go someplace out on the internet. It doesn't matter where you go. I'm going to pick a web page in this particular example. So I'm going to let this guy run. So it's going out to an IPv6 address. Now take a look here. First of all, because we ran ipconfig/all, we know that our internal network starts with a 2603. So this is my internal network, and now this is going out to probably my gateway router and then a bunch of other connections. So the idea here is you get to know all the routers to get out of the internet. So for me, I've got one internal router, and then I've got one gateway router out to the internet. Let's do this again, because you don't have to use a web page. Just pick some arbitrary FTP site. Now this is an IPv4 one, so let's watch. So there's my internal router, that total home 192.168.4. There's that 96.120 is my gateway router out to the internet. And here's all a bunch of, this one's far away, man. We got to go and go and go. So you'll see here on traceroute, we're starting to see some asterisks. That's because some routers are designed not to respond back. But it's still okay. What it's showing us is that we're out of the internal networks and out to the internet. Look, if the internet goes down and it's one of your routers, then it's your problem. So I could run traceroute again in the future, and let's say I only get one hop, just one. It never gets to my gateway router. That's telling me there's probably something between my internal router and my gateway router that I need to deal with. Traceroute is an incredibly powerful tool. Just run it before you have any problems and know all of your internal routers. If something breaks down out there in the world of Comcast or something like that, you're not going to fix that, but at least you're aware there's nothing wrong with the routers for you to get out to your ISP. Got the idea? The other one I want to talk about is ping. Ping is one of these commands that does so much goodness for us in one shot, it's not even funny. Like for example, I'm going to just run ping real quick, and I'm going to ping my router. Because I know what my router is, because I've looked with ipconfig/all and I have it memorized. So I run this and I get a reply. I automatically know that I've got a good IP address on this system, and I know that the router is responding, so it's probably up and running. Ping is an amazing tool when used properly. Here's another trick you could do with ping. Watch this. Now I'm going to run a ping here, and I'm just picking some arbitrary FTP site in this case. Now look, it's timing out. Do you see that? Who cares? What I want you to do, let's look at this one more time, and I want you to recognize something very, very important that's happening. I pinged a fully qualified domain name and it returned an IP address. Do you see that 134? You want to know if your DNS server is working? Just try to ping something by its fully qualified domain name. Bah! You don't have to use NSLOOKUP or any of that stuff. Just a quick ping by a fully qualified domain name is the best test of a DNS server you could possibly think of. Now, I can only give you a few ideas in this episode about troubleshooting networks. Keep in mind that there are lots of tools out there you can get for all kinds of things, but for me, 95% of the time, I fix all of my network problems with just ping, traceroute, and ipconfig. Use those three tools. You're going to see them all over the exam. Practice with them, play with them. You're going to love them. Everything in IT needs power, but it's your laptops that really need power because we have the audacity to pick these things up and walk around with them. So what I want to do in this episode is talk about power and power management. Now, when I say power and power management, what I'm talking about is this thing is going to run on a battery. So I want to do anything I can to keep this thing happily running on a battery for as long as possible. So the first thing I want to start talking about is this beastie right here. It's an AC adapter. We've all seen these. These are the guys that we plug our laptops into and it charges the battery, right? Well, first of all, you got to be careful with AC adapters. Number one, this is the one place where I tend to buy directly from the manufacturer. For example, if I've got a Dell, I tend to buy Dell AC adapters just because I've had a little bit of bad luck with third-party ones, although there are third-party ones. Number one, this is the one place you might get a proprietary connection. You might have USBs and all kinds of stuff, but power still uses proprietary connections. And you need to make sure you have the right proprietary connection. Just because it looks right, that doesn't necessarily mean it is. Remember, with your AC adapter, you're going to have a particular voltage and you're going to have a particular amperage. And you certainly have to match those. But not only that, you'll often have a polarity. So it'll be a plus minus or a minus plus. The center is minus, the outside's plus, or vice versa. If you don't have the right polarity, you're not going to have the right AC adapter. So there are lots of folks out there who will get you the right AC adapter. I don't know about you, but I've left these in the back of Ubers and trains and all kinds of stuff. So if I replace them, I'm aware that there are third-party people out there, but I tend to stick with the actual manufacturers themselves. Okay, you got a good AC adapter, but you're not getting power to your laptop. The next thing I'm going to be checking is the actual jack. If the jack is bad, well, we have episodes that show you how to replace that. The other thing to watch out for is if you've got a laptop, you're plugging it in, it runs great. The moment you unplug it, it's bad. Two things are happening there. Either number one, your battery's dead, and batteries die, or your actual charging circuit inside the laptop itself is bad. If it's a bad battery, you can take it to a battery tester who can verify whether it's good or bad, or you can just buy a new battery. Keep in mind that the vast majority of batteries we use are lithium ion or some derivative of them. And a lithium ion, if you can get one to last for 2 years, you're doing great. But do keep in mind that they die and you replace batteries. It's just welcome to the club. Okay. The other thing I want to talk about is the concept of power management. In particular, I'm talking about the built-in functions. They're actually built into your CPU called ACPI. ACPI is about 20 years old, but we love it and we use it. Anybody who's ever said, oh, my computer went to sleep, or if you've ever heard the term hibernate, what you're really talking about is ACPI. So in order to work with ACPI, you're either going to be working within your BIOS or you're going to be working within the operating system. It really depends what you want to do. So first of all, let's go ahead and take a look at a typical BIOS. If you look at this BIOS right here, you're going to see it has a lot of power on by keyboard, power on by mouse. You can have it wake up by time of day, all of these types of things. That's the primary function of BIOS. Keep in mind, when your machine's asleep, you don't have an operating system. So waking up is a BIOS job. Now there's one other thing I want you to take a look at on that same screen. Do you see right here where it says soft off by power button? Let me change that. And you'll see it says instant off or delay 4 seconds. Now what we're talking about here is the actual power button on your system. Now keep in mind, I'm talking about laptops, but this works exactly the same on a desktop as well. And that means that button that you're pressing, it doesn't really turn off the power. That button is not like a light switch where it actually just cuts off the electricity. It really just talks to the intelligence of your motherboard and your CPU and lets you program what you want it to do. For example, I could press on my button on my laptop here. If I press it, boom, it turns off the computer. Or I could press it and it waits 4 seconds and then it turns off the computer. Or I could even put the computer into hibernate mode, which we're going to talk about in a moment, by pressing the button. That BIOS we just saw doesn't have that option, but other BIOSes will. One thing you'll see on laptops is what happens when you close it. It's also a soft power function. When I close it, does it actually shut the laptop off? Is it going to just put it into a sleep mode? And you can program this, but again, you're going to have to count on the BIOS for that type of setting. Pretty much everything else is handled in Windows. But first, before we get into Windows, I want to make sure we understand that ACPI has power states, and they're numbered S0 through S5. Now, a lot of times when you go into BIOS, you'll see things like wake on LAN at S5 or something like that. I want to make sure you understand what these S levels are because you don't even have to know them all. First of all, either ACPI is enabled or it's not enabled. On most systems today, it's just enabled when you power up the computer. You can't even turn off ACPI anymore. So ACPI S level 0 basically means it's on, but nobody's using it. We haven't got anything turning off or whatever might be happening. The next level is going to be what we call ACPI level 3. ACPI level 3 is what we call a sleep mode. Now, when your computer goes into a sleep mode, your CPU stops working, but your RAM keeps running. So whatever is in RAM at any given moment, it kind of like freezes it right there, and it's going to be sitting there, and RAM's going to be continuing to be powered and keeping it there until you're ready to come back to your system. So a sleep mode is pretty easy to come back from. When we get to ACPI level 4, what we're talking about there is hibernation. Now, hibernation means everything that's on RAM is copied to a file on your hard drive, and then even RAM is shut off. So hibernation uses a lot less power than sleep. However, it takes a lot longer to come out of hibernation mode. You can actually see the file where all your hibernation settings are stored. On a Windows system, it's in the root directory of the C drive. Let me show it to you. So I've already popped up a command shell, and what I'm going to do is I'm going to type dir/ah, show me all the files with the hidden attribute. And if you take a look right here, do you see hyberfill.sys? That is actually where your RAM is copied to when your computer goes into hibernate mode. So when would you choose sleep versus hibernate? Well, it's completely up to you. The only benefit is that hibernate uses even less power than sleep, but it takes a little bit longer to come out of. So keep that in mind when we make some choices here. Okay, so let's come back into Windows now. And this time what I want to do is actually configure our power. Now you can do this through settings, but I'm a little bit old school, so I still do it through Control Panel. And we're looking for power options right here. So what Windows likes to do is that it creates what's called a power plan. So it's going to make 2 power plans for you, balanced and high performance. So balanced is basically, if I'm at ACPI level 0 and I'm running full speed, I can still turn off a monitor without going into sleep mode. I can still turn off a hard drive without going into sleep mode. Get the idea? So even at ACPI S0, I could say turn off the monitor after 3 minutes. And I'm still wide awake, just hit the keyboard and boom, I'm right back. However, it does cut down on a lot of power. Your system by itself, the CPU and RAM, compared to your monitor and a bunch of spinning hard drives, doesn't use that much power. And if you want to save power on a laptop, turn off the monitor, turn off the hard drives, and you're going to be doing really, really well in terms of power saving. So if I want to, I can have some other choices. For example, choose what the power buttons do. And this is that soft power. So if I want to, I can say when I press the power button on my laptop when I'm on battery, I can go into sleep mode, or I could completely shut down the computer if I want. This is where I make those choices. When I close the lid, when I'm plugged in, I go into sleep mode, but maybe when I close the lid, I want to go into hibernate mode. So this is where I can make those types of choices. I'm going to save those. I like those choices. So choose what closing the lid. That's pretty much going to bring us right back to the same spot. If I want to, I can actually create a power plan. Now, a power plan, they give you my 3 choices here. You can make your own custom plan. We're going to look at the balance plan, though. So it's going to give me settings for my display and actually for just my putting my machine to sleep. That's not hibernate mode. Now, if I want to, I can change the plan settings and I can go into advanced power settings, and now I can be extremely detailed about how I want things to work. For example, what do I want my wireless adapter to do? So I want to set it for, they have a medium power setting. We can actually go in there and detail that if we want to. Even things like my PCI Express slots, all kinds of stuff, I can configure this at a very, very detailed level. The bottom line is that the biggest problem most people have with power management on a laptop is that laptops magically do things that they don't know why. I'm sitting here working away and all of a sudden my computer turns off. Well, folks, you need to take some time and go into your power management plans and configure them to work the way you need them to. And also remember, closing a lid or pressing a button is extremely programmable. If you don't like what your buttons and your lids are doing, change them. Is there anything more terrifying than to suddenly come home and discover that you don't have your smartphone, that you left it in a cab, or you dropped it on the street, or you got held up and somebody took it from you? The bottom line is that if somebody gets the information on this device, you're in a lot of trouble. Our banking is on here, personal information, all of our contacts and friends and phone numbers. Who knows what's on there? And the last thing we want is anybody to get to this information unauthorized. So hopefully I'm really preaching to the choir on a lot of this stuff, but let's go over what we need to do to keep our smart devices secure. So the first one, and the big one, is going to be a screen lock. It blows my mind away how many people still don't use a screen lock. They have to do is they go up to their phone, they press a button, turn it on, and you're in. And all I got to do is go to your bank account or go over to eBay and buy stuff. Not a good idea. So screen locks are really, really important. Now, screen lock functionalities are very similar between Android and iPhones, but I'm going to do this one on an Android. What I'm going to do is I'm going to go into settings, and I'm going into security and location on this version. And right now you'll see the screen lock says none. So what I'm going to do is I'm going to look at my options. So I can do a swipe, which is really no screen lock at all, but it does require you to at least swipe it. I can make a pattern. I can type in a PIN code, or I can type in a password. So let's go ahead and try pattern. So I'm going to have to give it some pattern. And what am I going to show on the screen? Okay, so you've got a lot of options when it comes to setting up a screen lock. Keep in mind that you can also do things, for example, face recognition. Now, we can't really do that in Android without third-party apps, but it is now built into iOS devices. Here's an example of one. Now, if you want to take it another step further, you can do multi-factor authentication, which simply means doing more than one of these. Now, It's not very common on a screen lock to see multi-factor authentication. It can happen, but we usually do it with individual applications. Like for example, I might have a particular program where not only do I have to log in with a passcode, but then it's going to then call my cell phone and text me back a number, and then I have to punch that in. So it's requiring 2 authentication factors, and anytime you're worried about security, multi-factor authentication is the way to go. All of my banking tools, all of my health tools, all use multi-factor authentication. No exception to that. Now, while you're logging in, sometimes you might forget things like passcodes or patterns or things like that. So you will have a number of failed login attempt restrictions. So basically, like let's use iPhones as an example. After you try logging in a certain number of times, it kind of puts you in timeout and makes you wait a little bit longer until you can try again. There is a setting on iPhones, for example, that will set the number of times you can attempt before it erases the phone. So here's an example of that setting on an iPhone. The other handy tool are authenticator apps. A lot of times, especially if I'm using a tool like, for example, Google, or if I'm using Microsoft products, I'm constantly logging into all these different apps. So what I'd like to have is some kind of authenticator app which adds an extra layer of protection. So on this phone I actually have one. This is the Microsoft Authenticator app, and what you're looking at here is a code that I have to type in. So if I'm logging into a Microsoft product where I've activated it to use this, not only will I have to log in through a passcode or username and password, whatever it might be, but then it's going to tell me to punch in this code as well. So the only downside to Authenticator apps is that once you set up an application to use them, if you lose your phone, you could often be in trouble. So for example, Google has an authenticator, but it comes with backup codes. So that if you ever run into trouble, you actually have these codes. So when you get your new phone, you can use one of these codes and get around that type of stuff. So be careful with authenticator apps. The other thing we run into with these phones is that we lose them. And we're nervous when we lose them, and understandably so. So one of the things we'd like to be able to do is, number one, find our phone. So both iOS and Android have wonderful tools. It's called Find My iPhone in the iOS world, and in Android it's called the Android Device Locator. So I've got Android Device Locator running right now. So all I had to do was go to Android Device Locator, type it in, and this popped up. Now if you take a look, it actually shows my phone. Yep, that's where I am right now. Fuqua Street in Houston, Texas. Yeehaw! All right. So I've got a couple of options here that are handy. For example, play sound. So if I hit this,
it's for you, Mike. It's for you, Mike.
Isn't that a great sound? Okay.
It's for you, Mike.
Stop! There we go. So that's one thing. That can be often handy when you drop your phone behind the bed and you can't find it. The other one is that you can lock the device out and just lock it out so that nobody can get to it. None of your login stuff will work, and you're going to have to actually go back and open the device through a different computer on a Google account. And the last one that's kind of handy is Erase Device. So on this one, I can just click on this and it will completely erase everything on this phone. And again, pretty much iPhones have the exact same options, and it is a wonderful and handy tool. The other type of security I want to talk about is something that's a little bit more aggressive. And this is called, basically, it's under the umbrella of what we call mobile device management. When you're in a corporate environment, you really have some amazing tools when it comes to what you can do on a phone. For example, if I have what we call bring your own device, BYOD, it's kind of limited in terms of what you can do, because I own the phone, and if the company wants to put their stuff on it, that can often be a question mark. So what you'll see instead is you'll see corporate owned devices. So what'll happen is now I've got my Total Seminars phone. Now, if you have that, you have enterprise level controls that you can do all kinds of amazing things. You can set up security policies, you can do all kinds of really lockdown type of stuff, big passwords, anything you want. In fact, one of the big ones, and I want to make mention of this because it happens a lot, is somebody hands you a phone from the corporation. You're like, hey, I got a phone here, so I'm going to play some fun game with Pokemons or something, and so you want to install Pokemon Go, and you go into the store, and you know what? That's not an option. And that's because in corporate-owned devices, they can actually whitelist only certain applications that can show up in the store. It's a very, very powerful tool. If you want to learn more about that, take my Security Plus course. We go into an amazing deal on MDM. Hello folks, it's the great Mike Strami once again dealing with issues that will show up on the A+ exam in terms of troubleshooting. Now what's actually very interesting is that CompTIA decided to come up with a whole bunch of mobile device security symptoms and how we're going to deal with them. So in this particular episode, the Mike Strami will only be dealing with security issues that you're going to see on your mobile devices. However, I'm going to tell you something. As we go through these, I personally feel that a lot of these symptoms can show up in non-security related problems. So you're probably going to see some of these again, except we're going to be talking about them from a non-security in another episode. So you guys ready? Bring on the problems. What do we got first here? Okay, signal drop or a weak signal. Yes, that can most certainly manifest as a problem in terms of security. That's a very scary one, in that somebody might actually be turning down your connectivity. This is a classic example of what people want to do when they're going to be attacking your device, because they don't want you connecting or updating or anything being checked. So this is the first thing that they're going to do. This will be an incredibly obvious thing though. It's not going to be like, you know, you're going to be in the middle of Antarctica and suddenly your signal drops. You're going to be in the middle of a big city where you should be having 5 bars and instead suddenly everything drops off completely. In that type of situation, when you know you should be having good cell connectivity, good Wi-Fi connectivity, good Bluetooth connectivity, and suddenly it disappears, that's a concern. My answer is I'm going to be turning that phone off, like completely off, and then I'm going to be checking it out later. Another big one is they're going to be using a lot of things on your device. So you're going to do things like power drain, slow data speed, high resource utilization, data transmission over the limit because they're grabbing a lot of data. All of these collectively point to somebody who has put something on your system. Now, it's almost certainly going to be an Android device if this happens. Go Apple. And the only real answer there is to run some form of anti-malware because somebody's got something naughty on your system. However, I will also put in the caveat that a lot of times anti-malware for Android devices, while good, is an imperfect thing. And a lot of times, if I see stuff like this, I'm going to start checking accounts. I want to see if there's something weird happening anywhere in hopes that I might find something bad enough. The end result is I'm changing all my passwords all over the place. I mean everywhere. And then I'm going to be going in and I'm going to do a factory reset on that device and reinstall from scratch because I'm paranoid, that's why. A couple other ones you're going to see that will happen from time to time is like an unintended Wi-Fi connection or an unintended Bluetooth connection. These are very tricky because you'll say, did I make that connection? Because I don't remember whether I did or not. What I like to do to avoid this is, in particular, a lot of these big widespread Wi-Fi connections like AT&T Wi-Fi and things like that, I avoid them like the plague, primarily because it's too easy for me to suddenly be on an AT&T connection when I wanted to be in the coffee shop. And a lot of times bad guys will use these broad connections to get you connected to do whatever nefarious things that they want to do. So you definitely want to watch out for these problems. And in general, what you're going to be doing is you're going to be wiping that device completely and you're going to be installing from scratch after aggressively changing every single password you have. And I hope you're not one of those people who uses the same password for everything, because it will absolutely murder you. Let me give you a little clue. Every time you go to an application or to a website, there's going to be some aspect of what you're connecting to. I don't know, Dropbox.com ends with an X, wink, wink, nudge, nudge, where you use a base password and then you put something in there. Also, make sure you're using very complicated passwords. So unless you actually knew the phone number where I was growing up in St. Louis, Missouri on Portis Avenue, combined with the search radar used in the F-14D Tomcat fighter plane, put those together, you're not going to have much luck trying to figure out my passwords. The other symptoms that they show to me aren't symptoms, they're bad. It's not a symptom, it's the fact you've been attacked. Things like leaked personal data and files, or you've got personal information suddenly showing up. You're getting these emails with Bitcoin accounts going, I've hacked your system. They'll actually put a password in there. They got you, man. So this is bad. Unauthorized account access is suddenly your Facebook is showing up with things that you never put there. Unauthorized location tracking, where suddenly people are going, hey Mike, I saw you were at blah, blah, blah. Whereas location tracking should be incredibly private. Unauthorized camera, microphone activation. Suddenly people have recordings of you talking at the coffee shop with your favorite barista. Where did this come from? Folks, those aren't symptoms. Those are the results of a hack. In those situations, you go absolutely bananas. Number one, you wipe that device completely. Number two, you go online, do whatever you need to do. You get to every single one of these accounts and you change the passwords. And number three, you take solace in whatever entity or spirit or philosophy that you choose and hope that that person hasn't caught one place with one password where you were doing something you probably shouldn't have been doing in the first place. What? Another Mike Strami right after another? You lucky people, that's exactly what it is. Let's call this the Great Mike Strami Part 2. Anyway, in this episode, what I want to be talking about is not really security errors, but just generic problems that we run into with our smart devices. So we've got a big list to go through, so let's knock these puppies out. Number one, inaccurate touch screen response or a touch screen non-responsive. To me, that's the same thing. Your touch screen is messed up. A lot of times, if the system is heavily overloaded, your touchscreen moving really slowly and jaggedly is a sign, not that there's anything wrong with the touchscreen, but because your system is just too full of stuff. What I would recommend is restarting the system, seeing if that makes it go away, and if it comes right back, you've probably just installed too many apps. Smart devices are still computers. They have RAM, they have hard drives, and you can overtax them with putting too many things on there. So if you do by any chance have a smart device that has calibration capability, which isn't very common, you can try to recalibrate, but in my experience, going through, rebooting the system, have you tried turning it off and turning it back on again, as well as removing applications, should get you out of trouble there. Okay, the other one is a dim display. Not a black display, but a dim display. The first thing I'm going to say is, well, turn up the brightness. You know, a lot of these devices will actually have a manual slider to set the brightness on the device, or maybe there'll be a little switch on it. Make sure you're turned up all the way, and also make sure that if you're using the auto brightness, make sure that that's turned on, and you should be okay. If you're still dim, remember that it's still a smart device, it's still a computer. These devices go away after a while. You can actually, on some devices, actually repair dim displays by replacing backlights, although it's pretty rare, and on today's system, unless you've got a real high-end system, the answer is you throw it away and replace it. I currently have a stack of about 20 different smartphones that I've used over the years, and they just have a limited lifetime on them. Cannot broadcast to an external monitor. Okay, I've run into this one a few times. Number one, are you on the same wireless network as whatever this other monitor is? So if you're going to be doing some kind of broadcast, you've got to say a Roku device or something like that. Number one, make sure you're on the same wireless network. And number two, and this is a big one that gets people in trouble, make sure that you're actually trying to talk to the right external monitor. This can be a real challenge when you're broadcasting, and you could literally find yourself trying to talk to your next door neighbor's device, and then you get that phone call that happens. And also do keep in mind that you can't instantly assume that all external monitors will instantly work with your device. So check with the manufacturer and make sure that it'll work with your device. No sound from speakers. Oh man, that happens to me all the time, especially when I forgot that I had already paired my headset to it, and I left the headset on my bedstand, and now I'm over at my desk and I'm trying to play a YouTube video, and it's working just fine, but unfortunately it's going out to a different set of speakers. Number one, make sure volume isn't catching you on these particular things, and then also depair any Bluetooth devices. Okay, intermittent wireless or no wireless connectivity. To me, those are almost the exact same thing. Intermittent wireless, we have other episodes that cover this in great detail. We're talking about the same type of problems you'll run into any other place, with any other, or a desktop or a laptop or anything. We're talking about interference issues more than anything else. And if it keeps up going for a while, you might want to consider a site survey because your office next door just put in a huge old 802.11 AC system and they're eating up all of this band spectrum and you're going to have to move. That might get rid of that. No wireless connectivity at all. Now, this is assuming that you can actually connect to the SSID. Now, that would be troublesome for me if I were to see something like that. I would be curious about my distance. I'd be curious about the SSID, the wireless access point itself. Are the antennas okay? Something like that. But I think what CompTIA is talking about is you can't even log into the SSID. If that being the case, also keep in mind that these devices have profiles, and if somebody's changed a password or something, even on a well-known SSID that you've used 100 times before, it's just not going to let you catch in. No Bluetooth connectivity is an interesting issue. Bluetooth is a persnickety bit of witchcraft at best. And a lot of times, if I'm trying to connect to something and I'm having trouble, number one, make sure that the device you're trying to connect to is in discoverable mode, which is often not the easiest thing to do, especially if it's like a set of earbuds or something like that. You also might want to keep in mind that someone else isn't already paired to that device, which will keep you from connecting to it. And last, make sure your Bluetooth is turned on. I can't tell you how many times I've made that mistake. Okay, app errors. So we got apps not loading and app log errors. All right. Apps have their own way of doing things, particularly in iOS and Android. Most apps will have some feature that can cause this problem. A big classic problem is many apps use caching. And in order to clear the cache, you're going to have to look at how you clear the cache for any one particular app, clear it out, and try again. You can do a force stop to shut the application down and to start it back up. And if that doesn't work, shut down the entire phone and try logging back in again. At the very worst, you can always uninstall the app and then try reloading, and then double check on Google. On these types of issues, invariably, you're not the only person having that problem, and you can figure out what's going on at that case. All right. Slow performance. That one's easy. You're running too many apps. You're running too many apps. I know so many people, they buy a phone and they run too many apps. So stop running so many apps, because that's exactly what it is. It's not like you can upgrade the RAM in your smartphone, so stop running so many apps. Got it? Okay, what else? Extremely short battery life. Extremely short battery life always points to you're burning too much battery. Things like GPS, for example, is a big eater of battery life. Anything that's running real time in the background, constantly syncing or something like that, is going to be burning CPU cycles and is going to drop your battery life considerably. What you need to do is take advantage of tools that are built into both iOS and Android, which will literally say, list all my applications by how much electricity they're eating and find the bad guys at top and knock those out. What else? Overheating. Overheating is incredibly dangerous. All smart devices have thermal trip switches built into them that should prevent a device from getting too hot. They will fail sometimes, number one, if you don't provide any form of ventilation. Putting a device in a place between two books, for example. I've seen that happen where it can overheat. Also, unfortunately, lithium batteries are dangerous in and of themselves. Did you know every jet airliner, every commercial jet airliner in the world actually has a big metal tin that is on the plane that's designed for one reason, and that is to drop a laptop or a phone or anything that's on fire so that it can be contained and not make the airplane crash. These are real problems. They're working it all the time. Batteries have never been safer than ever. There's just so many of them. What else we got? Frozen system. Frozen system invariably can be pointed either to a problem with an app. A lot of individual apps, because they're streaming or apps or something, they're actually end up stealing a lot of CPU cycles because they're waiting for something to happen to come in from the network. And a network stall, and this is where things like wireless connectivity issues can also manifest, is that suddenly you have, it's really not the whole system locking up, it's just that app, but it can cause trouble, and it can often lead to what we call the black screen of death, which is the kernel panic for Android devices. And the answer, once again, is you're going to have to trace it down to whatever particular application is causing the problem. and delete the application and wait for them to come up with a patch so that that problem won't continue. And the last one, and this is a bad one, and to me this is almost more of a security problem than anything else, and that's system lockout. If you've been locked out of a system, something bad has probably happened. Let's assume that it's not evil. Let's assume that you've typed in a password too many times. If you've got that kind of system lockout, for pretty much all operating systems, the answer is a factory reset and then a reinstall. And to be honest with you, I don't think that that's necessarily a bad idea, because often a system lockout simply points to somebody else was trying to do something evil, especially you got that good deal. So this guy's trying to sell you a $1,000 phone for 200 bucks, and it's got a system lockout. It was probably stolen.